Hi everyone, just wanted to take a minute to talk a little bit about trapezoids. So a trapezoid is our next type of quadrilateral. We finally left the world of parallelograms. So the big difference between a trapezoid and a parallelogram is that in a parallelogram we have two sets of opposite sides being parallel, and in a trapezoid we will only have one set of opposite sides be parallel. Okay, so we will only have the one side. So in this case it would be these top two. If it had two sets, it would just be a parallelogram. So there's a couple important pieces of information to know about trapezoids. Most notably that if they have two sides that are congruent, called the legs, if they have two legs that are congruent, this would be something called a isosceles trapezoid. And an isosceles trapezoid has a lot of different properties. So an isosceles trapezoid will have congruent angles down at the bottom here, right? These two will be congruent, and conversely, so will these two. The diagonals will also be congruent, which you could use doing a simple side angle side proof. And then additionally, those criteria that we just went over would also be able to show that a trapezoid is isosceles, okay? The other thing that is true for all trapezoids is that if you have the median or the mid segment, either is acceptable, of a trapezoid, it is parallel to the bases. Okay, don't forget, we have base 1, base 2, leg, leg. So if I connected the two midpoints of the legs, I would get something called the mid segment. You might also see the word median, but I typically use the word mid segment. It is going to be parallel to these two sides, and the length of it will be equal to the length of this base plus this base divided by 2. Okay, so that will ultimately be that measure. So, for example, if we had to find the value of x, given that this is a mid-segment here, we would know that this length, 17, is equal to 1/2 BC plus AD. 2x plus 1 plus 3x plus 8. Okay, so 17 is going to be equal to 1/2. What's this going to be? 5x plus 9. I'm going to multiply both sides by 2 to get rid of that 1/2. So I get 34 equals 5x plus 9. 5. Okay. I'm going to subtract the 9. So if I were to subtract the 9, that would be 25 equals 5x. So x will equal 5. All right. And that makes sense, right? If I plug in 5, this would be 15 plus 8, which is 23. 23. If I plug in 5, this would be 10 plus 1, which is 11. And 11 plus 23, 34 divided by 2 is 17. All right. So that is ultimately how you use that for the mid-segment. And now, if we wanted to figure out if an isosceles trapezoid, or if this is an isosceles trapezoid, what would we have to do? Well, we would have to first start off by showing that it's a trapezoid. And again, if we go back to our definition of what a trapezoid is, it says we have a pair of parallel sides. Okay, so we would have a pair of parallel sides. So that's where we're going to start. From there, what do we need to show? Well, we can show it's isosceles if we can show that the legs are congruent, which would be distance formula. We could show it's congruent, we can show it's isosceles if we know that the angles are congruent, which I don't really know how to do that with coordinates unless it's right angles. And if it was, then it would not be a trapezoid. I could show the diagonals are congruent, but that's also going to be the distance formula. So ultimately, we're just really going to have to use the distance formula. All right. So in order to do this, you will need to do some distances. Let me just quickly draw a sketch so we know what this looks like. -3 up 2. Okay. Over 1 up 3. B. C over 5 up 0. C. And then D is over 5 down 4. Okay, so that does actually make life not terribly hard. So what do we need to show would be parallel. So we will need to show that AD is parallel to BC, but just based on this quick little drawing here. We also would need to show that these are not parallel to the other one. So I still need to find my slope. So let me find this. Let's find the slope of AD. Change in y, -4 minus 2, -3 minus 5, -6 over -8 is going to be oops, I made a mistake. I'm sorry. I did my slope backwards. I said -4 minus 2, and then I switched, so it should be negative. It should be 5 plus 3. There we go. So that would ultimately be -6 over 8, which makes sense based on the picture. That's why I paused for a second. I was like, this should be negative. All right, so that would be -3 over 4. Now, if we did this correctly, BC should also be -3 over 4. And if not, it will not most likely be a trapezoid. All right, so BC would be what? 3 minus 0. 1 minus 5. So 3 over -4. So these are the same, so this is parallel. So these two are parallel. We do now need to confirm that these two will not be parallel. All right, so let's just confirm that. The slope of AB and the slope of CD. So AB is going to be change in y, so that would be 3 minus 2, 1 plus 3. That should be 1 over 4, which is not that. And then CD is going to be the change in y, which is 0 plus 4 over 5 minus 5. That's actually undefined. So that's undefined. So these are not parallel to these ones. Okay, so that's good. So this is going to be a trapezoid. Now, in order for us to show that it is an isosceles trapezoid, so trapezoid. Okay, so now in order for us to show that it is an isosceles trapezoid, I have to show that these two lengths are the same. So let's look at the distance of AB. So AB can be the distance formula, change in y over change in x. So x2 minus x1, so 1 plus 3 squared plus 1 plus 3, 3 minus 2 squared. Okay, so that's ultimately going to, let me just make sure I did that right. Okay, yep, so that'd be the square root of 4 squared plus 1 squared, which is just going to be the square root of 16 plus 1, which is the square root of 17. Let me just make sure I did that correctly once again. So that would be -3 minus 1, so 4. Yep, okay. So we are good. That is the square root of 17. The other one, this is a vertical line, right? And I could just count. I go from -4 up to 0. So the other one just has a length of 4. So despite the fact that these look very close to being isosceles, they're not actually isosceles. They're very close, but they're not. So because this is a trapezoid, but it does not have congruent legs, this is not isosceles. All right. And ultimately, if they had been the same number, it would have been isosceles. I personally think that's probably going to be the easiest way for you to show that something's an isosceles trapezoid, but you are welcome to use the diagonals if you would prefer. All right, let me know if you have a question, and have a wonderful day.